Hey, what's going on, geometry class? We are going to close out the year with one last final project. I know that you guys just got excited hearing that. Yes, more geometry. All right, we're going to make Tommy Trigg proud with this last project, and we're going to measure the flagpole outside of the high school. Now, I was going to show you guys what that's going to look like, but unfortunately, our old flagpole seems to have gone missing in a storm. So instead, we're going to be measuring this electric pole here, and we're going to see how high up that goes. Mr. Sims probably isn't going to like me sending my class out there, all of us trying to run up a flagpole. And if I was trying to measure this pole, I'm going to have one heck of a time trying to do it with this little tape measure. Thankfully, we're not going to need this. I'm not going to be climbing up any electric poles. That's not part of my skill set. But what is part of my skill set is trigonometry. We've been learning the past month about how we can use trigonometry and our trig ratios to solve for missing side lengths and missing angles. What I'm going to do is I'm going to take the measurements that I can easily and use trigonometry to set up a ratio for me to find the length of that electric pole. We're getting tricky with it. So I may have fibbed just a little bit. I am going to need the tape measure, but not to measure to the top of that. Actually, my first measurement that I want to take is I want to stand so far away from the electric pole, so I'm going to measure that out now. Alright, so I decided to use the full length of the tape measure, which is exactly 300 inches, and that converts exactly to 25 feet. Alright, so by now you guys should have made your clinometers that you're going to use to measure your angle. I need an angle now, but sadly I am without a protractor. This is where I insert sad face. So instead, I found an app on my phone that I can use, but I'm still going to need some hardware. And so I got my straw here, and I'm going to tape it to my phone. Alright, so this is my clinometer app, and I have taped the straw to my phone. So I'm going to look through the straw. I'm going to first make sure that I am parallel with the base of this triangle that we are creating. And so my sister, who is helping me out with the camera, she's going to let us know when we're at 90 degrees. And then once I'm at 90 degrees, I'm going to point and look to the top of the pole to see how many degrees change that is. Alright, so again, I'm trying to be parallel to the tape measure. I'm in line at that 25 feet there. Alright, so I should be close enough to 90 here. We're about parallel with the base of the triangle. I'm now going to look up, and we are going to take that degree measurement. I'm looking for the tippy top of this pole, and there it is right now. What are we at?
44.
Okay, 44. Wow, we have almost made a 45, 45, 90 triangle, and that was all by happenstance, but not quite what we're looking for, or not quite what we ended up with. Let's actually do the measurements and figure out what we got. Okay, so since 90 degrees is going to be parallel with the base of our triangle, and after moving we ended up at 44 degrees, that means that we have to do 90 minus 44, which gives us 46 degrees. Now this angle is the actual angle that's inside of our triangle. Alright, so the measurements that we just took are good and should be pretty accurate, but we're a little bit off for actually finding the height of this pole. And that's because when I found that angle, I was taking it from my eyes, which don't actually go from the bottom of the pole. Okay, they're actually up off the pole a bit. And so if we did the math now, we would find the height of the pole from right here, where my eyeballs are, to the top. I need to add on this bit down here, so to do that, I need to measure from my feet to Sorry, we had some trucks pass by. But like I was saying, we all know I'm about 6'2", so it's going to be a little bit less when you measure to the top of my eyes. So I'm going to go get some help so that we can measure there. Alright, some of you may be thinking at this point in the video, how does a teacher afford a house like that? And I don't. I live in a tiny shed. But I'm at my parents' house, and they're going to help me measure myself here. So I want to get up to my eyeball, so I'm going to put this underneath my boot and put the tape measure to my eye. And obviously I cannot see that measurement, so they're going to tell me that it is what?
63.5.
Alright, 63.5 inches?
Yeah.
Okay, so I'm actually having to record over this because we filmed this outside and the birds were literally just too loud. But anyways, we got our measurements, and my sister is standing in the middle of the road getting the shot so that we can see this triangle. I'm going to put that on the screen. So yeah, we're going to take all this information. We're going to go back to my place, and we're going to use some trigonometry to figure out how high that electric pole actually is off the ground. Okay, so now we are back at my place, and we are going to actually do the math to figure out the height of this electric pole. Now, as I go through this, I want you guys to fill out your paper, draw in the picture that I'm going to be drawing, and answer the questions that go along with it. Okay, so the very first thing that we're going to need in our drawing is our main piece of attraction, which is our electric pole. Okay, this is what we're actually trying to find the height of. This is probably the most important piece. Second most important piece is going to be this guy over here, which is me. This is where I was standing when I was taking the measurements for our triangle that we're going to create. So let's actually start building the triangle. So from the electric pole, from the base of it, I took my tape measure out 25 feet, and that's where I was standing. So this measurement here is 25 feet. Now, after I took that measurement, I used my clinometer, and from there, I measured up at a 46-degree angle. And remember, this is just from my eyes parallel with the ground to the pole. Okay, it was 46 degrees off of that. So there's our two sides of our triangle. The third side is going to be from the top of the pole down to where my eyes or from where my eyes would meet the pole. And there is our triangle. Now, not only is this a triangle, this is a right triangle. So I'm going to note that with our right angle here. And there we go. Now, something that we need to take note of is what we are actually trying to find. And what we're actually trying to find is the length of this segment here from the bottom of the pole to the top of the pole. This is going to be our height, and I'm going to denote it with a variable x. Now, this variable x is not, we can't actually find it straight away. What we have to do instead is we have to find this segment here, and I'm going to represent that with another variable. I'm going to call this variable z. All right, and just to make things a little bit easier for us to see, okay, we're looking at this triangle here. This side will also be 25 feet, right? It's just the same as this here. All right, so now that we have all the measurements of our triangle that's right here, let's go through and let's label the things that we know about it. So the first thing I'm going to label is the hypotenuse. So remember, whenever you do the hypotenuse, you always want to be opposite from your right angle. So here's our right angle. We want to go to the side that does not touch that, the longest side of our triangle called the hypotenuse. So we're going to label that with an H. Now, the next side that we're going to label is the side that we already know. So I'm going to go to this side here, which is 25 feet. Okay, this is the side that I am next to. Okay, I'm literally standing on it. Okay, this is our adjacent side. And that means that this side over here that we want to find, side Z, it's farthest from where I am at. This is going to be our opposite side. Now, we've got everything labeled, but we need to know what trig function we can actually set up with this. So I'm going to bring in our handy dandy SOHCAHTOA, like that should always be written on the top of our paper so that we can reference it. And I'm going to look at the things that I have. So I do not have any measurements for the hypotenuse, and this is not something I'm trying to find. So what that means is sine is going to be out, and also cosine is going to be out. Okay, I have no use for the hypotenuse, and I don't have any measurements for it. So I can't use it even if I wanted to. All right, what that means is that we are left with SOHCAHTOA and our TOA, which is our tangent. So we're going to be using the tangent function to set up our ratio here. All right, so when we take the tangent, we need to take it of our reference angle. Our reference angle is the 46 degrees here. So we're going to take the tangent of 46 degrees. We're going to reference SOHCAHTOA, TOA. At the top of our ratio that we set up, we should put our opposite side. So here's our fraction. On the top, we're going to put our opposite side, which we labeled as variable z. So I'm going to take our variable z. I'm going to bring that to the top. And then we're going to divide that by the adjacent side. So here's our adjacent side, the one that I'm next to. Okay, we labeled that as 25 feet. So we're going to take this 25 feet and we're going to put that at the bottom of our ratio. Now, if you remember, when x is up high, or in this case z, when z is up high, we are going to, I hope everybody in the room just said it, but we are going to multiply. Okay, so I'm going to take this 25 feet and we're going to multiply it by the tangent of 46. And that is what z will be equal to. Okay, and I hope you all know where we're going to have to go from here. We're going to have to take this to our calculator. Okay, so here we are in Desmos. I'm going to make sure that we are in degrees mode, and we are. And we are going to do 25 times the tangent of 46 degrees, and that will give us 25.888257884 feet. Okay, we are going to do what we typically do here, which is use our approximately sign, right, since we rounded. So we're going to take that, and we are going to round to approximately 25.89 feet. Now, that's good and all, but that's not what we were after. This is just the measurement for z. What we're actually after is the measurement for x. So there's one other measurement that I want to remind you of, and that is the measurement from the ground to the top of my eyes here. We need to add this piece on to what we already found to be 25.89 feet to find what x really is. So if you remember, this is 63 inches from the ground to my eyeballs, 63 inches. Well, we have an issue because we need to just add these two segments together, right? These two segments would, oh, this segment's a little bit crooked. Okay, but these two segments would create the whole electric pole here, which we labeled as X. But right now we can't add this one the way that it is because it is in inches. So what we need to do is we need to convert it to feet. Now there's 12 inches in every foot, so we're just going to divide 63 by 12, and we will get 5.25 feet. All right, so now that we have this, we can add these two measurements together and figure out what the height of this electric pole actually is. So I'm going to go back to my calculator, and we have 25.89 plus 5.25 feet. That's going to give us a total of 31.14 feet. All right, so our final answer we're going to say is x is approximately, because we rounded this 25.89, so we can't say equals to. And then we're going to take this measurement, and we found it to be 31.14 feet. All right, and there you go. We did not have to climb an electric pole or any poles or risk any danger. The only danger that we had was using too much of our brain power as we used trigonometry to find a missing side of a triangle, which was our electric pole. So yeah, plan to do that later in the week as we go outside and we bring math to the real world around us. All right, have fun making your kilometers, everybody. I will see you later on this week.